A thin cylindrical pressure vessel with an internal diameter of 4.6 meter and the wall thickness of 16 mm is subjected to internal pressure of 210 kilopascal. The yield strength of the material of the shell is 260 megapascal operating factor. According to the maximum shear stress theory, how to find out SYT we have given, and we have given here the thin cylinder. So we can calculate here the hoof stress and the longitudinal stress. Hoof stress will act along the x direction and the longitudinal stress will be act along the y direction. There is no shear stress in this case. So the diameter of the cylindrical shell is given as 4.6 meter, thickness is given as 16 mm, and we have pressure is equal to 210 divided by 1000 is 0.21 megapascal. The state of stress we can show as sigma x, sigma y, tau xy. Sigma x is same as the hoof stress. Sigma y is same as equal to longitudinal stress, which is half of the hoof stress, and the shear stress in this case will be equal to 0. Once we calculate sigma x and sigma y, in that case we will calculate the average normal stress, then maximum shear stress, then sigma a, sigma b. We'll arrange them in the order of sigma 1 greater than equal to sigma 2 greater than equal to sigma 3. And finally we'll apply the tau max absolute equal to sigma 1 minus sigma 3 by 2 SYS divided by n. But we have given the value of SYT, so we'll use the value of SYT. In that case you have to additionally divide it by 2. And again we have factor of safety n. SYT is known to us. Value of SYT is given as 260 megapascal. So let's calculate the hoof stress first. Hoof stress is same as the pressure multiplied by internal diameter divided by 2 times of thickness. Pressure is equal to 0.21 megapascal. Diameter D 4600 is whole thing is divided by 2 times of thickness, and thickness is given as 16. So we have a stress acting along the x direction is same as the hoof stress, and the hoof stress come out to be 30.18 megapascal. Longitudinal stress sigma L is half of the hoof stress, that is equal to 30.18 divided by 2, which is equal to 15.09. Therefore we have sigma y will be equal to 15.09. So we know sigma x, we know sigma y, tau xy is equal to 0, so we can calculate two principal stress in state of a plane stress. Average stress is sigma x plus sigma y divided by 2, that is we have 30.18 plus 15.09 divided by 2 is 22.63, that will be megapascal. And using sigma x, sigma y, we can calculate the maximum shear stress also. The maximum shear stress is given as under root of sigma x minus sigma y by 2 whole square plus tau square xy. So we have under root of sigma x is equal to 30.18, sigma y is equal to 15.09 divided by 2, and we have whole square plus shear stress equal to 0. Is 7.545 will be megapascal. Then using the sigma average and tau max, we can calculate the two principal stress or a plane of a stress. One is sigma a, which is sigma average plus tau max. Second is sigma b, is sigma average minus tau max. So we have sigma a is equal to sigma average plus tau max. Sigma average is equal to 22.63 and tau max is 7.545. So we will get the value of sigma a equal to 30.175 megapascal. So these are the standard steps you have to follow in the maximum shear stress theory. Sigma b is sigma average minus tau max is 22.63 minus 7.545 is 15.085 will be megapascal. So sigma a is positive value, sigma b is also positive value but less than sigma a. So we'll assign the value of sigma 1 is equal to sigma a, sigma 2 is equal to sigma b, and sigma 3 will be equal to 0. So we have sigma 1 is same as equal to sigma a is equal to 30.175. Sigma 2 is equal to sigma b because it's a positive value is 15.085. and sigma 3 will assign equal to 0. You have to always check that sigma 1 is greater than sigma 2 is greater than equal to sigma 3. Now we can apply the maximum shear stress theory and we can find out the factor of safety. We have sigma 1 is equal to 30.175, sigma 3 is equal to 0. These 2 and 2 will cancel out, so we have SYT is equal to 260 divided by n. So in this case we will get a factor of safety n equal to 8.61. Factor of safety is 8.61. A thin wall cylindrical pressure vessel. So we have given here cylindrical pressure vessel having a mean radius equal to 100. So diameter will be equal to 200 mm. Wall thickness is 5 mm subjected to internal pressure P. The factor of safety you have to use equal to 2 and the yield stress in the shear is 100 megapascal. SYS is known. Maximum value of P in megapascal we have to find out. Pressure in this case we have to find out, and we have given the value of radius, thickness and the factor of safety. So we have mean radius will be equal to 100. So we have diameter D will be equal to 2 times of radius. That will be equal to 2 times of 100 is equal to 200 mm. And the thickness we have to use is equal to 5 mm. Pressure P you have to find out. Factor of safety you have to use equal to 2. And we have given the value of SYS, that is the yield stress in shear, equal to 100 megapascal. So if we use here the maximum shear stress theory, that is MSST, then we have tau max absolute value will be equal to SYS divided by factor of safety. So we have value of SYS is equal to 100 and factor of safety equal to 2. So you can use the maximum value of the shear stress, but absolute value is equal to 50 megapascal. Because of a thin cylinder, two stresses will produce. One is sigma H will produce. Sigma H is equal to pressure multiplied by diameter divided by 2 times of thickness. Pressure is unknown, so we have to calculate this value in terms of pressure. So we have pressure, diameter is same as equal to 200 divided by 2 times of thickness, which is equal to 5. So we have a hoop stress will be equal to 200 by 10, that equal to 20 times of pressure P. And the longitudinal stress is always half of the hoop stress, that will be equal to 20 times of P divided by 2, which is equal to 10 times of P. So state of a stress is represented here. Sigma X will be same as equal to the hoop stress. Sigma Y will be same as longitudinal stress, and we have shear stress equal to 0. Using sigma X, sigma Y, we can calculate sigma average and tau max. Then we'll calculate two principal stresses, sigma A and sigma B, and finally we'll arrange them in the order of sigma 1 greater than sigma 2 greater than sigma 3. Average stress is sigma X plus sigma Y by 2. We have sigma X is equal to 20P and sigma Y is equal to 10P. So we have 20P plus 10P divided by 2, that is equal to 30P divided by 2 is 15 times of P. Then we'll calculate the maximum shear stress in a plane of shear. So maximum shear stress is under root of sigma X minus sigma Y by 2 whole square plus tau square xy, tau xy 0. So this value is same as equal to sigma X minus sigma Y by 2. So tau max is sigma X, which is equal to 20P minus sigma Y is equal to 10 times of P divided by 2, that is equal to 5 times of P. One of the principal stress for two-dimensional state of a stress is sigma is sigma average plus tau max, and second value will be sigma average minus tau max. So let's calculate here sigma A. We have sigma average equal to 15 times of P, and we have tau max equal to 5 times of P, that equal to 20 times of P. And sigma B is sigma average minus tau max. Sigma average equal to 15 times of P, and we have tau max is 5P. So sigma B will be equal to 10 times of P. So maximum value is 20p, that will be equal to sigma 1. We have sigma 1 is sigma A is equal to 20 times of p. This is positive value, so we have sigma 2 is equal to sigma B is equal to 10 times of p, and finally we have sigma 3 equal to 0. All the time I am saying the same thing, sigma 1 is greater than sigma 2 is greater than equal to sigma 3. So we have tau max value, which one is the absolute value, is always obtained from sigma 1 minus sigma 3 divided by 2. We have tau max value already known to us is 50 megapascal. Sigma 1 value is equal to 20 times of P minus sigma 3 is equal to 0 divided by 2. 100 divided by 20, so we have pressure is equal to 5 megapascal. All the steps in the maximum shear stress theory are fixed. Sigma average, tau max, sigma A, sigma B, sigma 1, sigma 2, sigma 3, and then use the maximum shear stress theory and find out whether the factor of safety or required any unknown. This time we have to find out the pressure, and the pressure is come out to be 5 megapascal. A 50 mm diameter shaft is subjected to pure torsion, which induces a shear stress of 70 megapascal. The yield strength of the material of the shaft is 440, SYT is 440. Then the ratio of the factor of safety obtained by maximum distortion energy theory to that maximum shear stress theory we have to calculate. In this case, we have to calculate the von Mises stress in the case of distortion energy theory, and we have von Mises stress is sigma prime is given as under root of sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square, and is divided by 2. Then by distortion energy theory, we have von Mises stress will be equal to SYT divided by factor of safety n. Secondly, you have to calculate the factor of safety using maximum shear stress. So let's say this factor of safety equal to n1 in the case of distortion theory. For maximum shear stress theory, we have tau max absolute value is given as sigma 1 minus sigma 3 divided by 2 is equal to SYT divided by 2 times of factor of safety, let's say n2, and then we have to calculate the ratio of this factor of safety obtained by distortion, that is n1 by n2 we have to find out. We have given here the diameter of the shaft equal to 50 mm and is subjected to pure torsion. So whenever we have pure torsion, in that case the only shear stress exists on the shaft is 70 megapascal, and we have a circle centered at origin. So for pure torsion, we have value of tau xy is equal to 70 megapascal. For Mohr circle, you have to use the x-axis as a normal stress and the shear stress equal to tau. Both the point here is a pure shear, that is this point and this point. So Mohr circle in the case of pure torsion is nothing but a circle centered at origin. This Mohr circle intersect to the right hand side at the given point. This one represents the principal stress. Let's say this principal stress is sigma 1 is same as equal to tau xy, which is equal to 70 megapascal. On the left hand side it will intersect, that value will take as equal to sigma 3, that is the minimum value, will be equal to minus 70, and sigma 1 is greater than sigma 2 greater than sigma 3, so we'll assign the value of sigma 2 equal to 0. So one Mohr circle you will get passing through sigma 1 and sigma 2. One Mohr circle between sigma 2 and sigma 3. So we have a largest possible Mohr circle is between sigma 1 and sigma 3. We have to just substitute this value in the von Mises stress and calculate the factor of safety, and the maximum shear stress we can calculate n2. So we have one missile stress sigma prime will be equal to under root of sigma 1. Sigma 1 is equal to 70. Sigma 2 is equal to 0 square of it plus sigma 2 is equal to 0 minus is plus 70 whole square. Sigma 3 is equal to minus 70. Sigma 1 is equal to plus 70 square of it divided by 2. So from this we can calculate the von Mises stresses. So von Mises stress will be equal to 121.24 will be megapascal. So we can apply the distortion theory and we can calculate the value of N1. N1 is equal to SYT and we are given the value of SYT is equal to 440 divided by von Mises stress is 121.24. So we'll get a factor of safety close to 3.629. Then we can apply the maximum shear stress theory, which is tau max absolute equal to sigma 1 minus sigma 3 by 2 equal to SYT divided by 2 N2. 2 and 2 will cancel out. We have sigma 1 value is equal to 70, sigma 3 is equal to minus 70. So we have 70 minus 70 and we have SYT is equal to 440 divided by N2. In this case, you will get the value of N2 is equal to 440 divided by 140. That is close to 3.14. We have to find out the ratio of N1 by N2. That is the factor of safety in the case of distortion energy to the factor of safety in the case of maximum shear stress. N1 value is equal to 3.629 and N2 value is 3.14. So this ratio is greater than 1, is 1.154. A small element at the critical section of a component is in a biaxial state of stress with the two principal stresses being 360 and 140. So in this numerical already we have given the two principal stress. Higher value will take as 360 and the lower value that is 140. So sigma 1 is 360, sigma 2 is equal to 140 and the third principal stress will take sigma 3 equal to 0. The maximum working stress according to the distortion energy theory you have to calculate. According to the distortion theory, the maximum working stress is given by the von Mises stress, which is given as sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square divided by 2 and you take the under root. So we'll assign the maximum positive value is equal to sigma 1 is equal to 360. Sigma 2 is equal to 140. Since both values are positive, sigma 3 will be the lowest possible value that equal to 0. And all these values we have given in megapascal. So just substitute and solve this. So we have under root of first term we have sigma 1 minus sigma 2. Sigma 1 is equal to 360. Sigma 2 is equal to 140 and we have a square of it. Sigma 2 is equal to 140. Sigma 3 is equal to 0 square of it plus sigma 3 equal to 0, sigma 1 is equal to 360 and we have a square of it. Whole thing is divided by 2. Solve this, you will get the equivalent stress, that is a von Mises stress is given equal to 314.27 megapascal. 314.27 megapascal, close choice is C. So option C is correct. Same question is again asked in GATE 2017 exam. In a metal forming operation, when the material has just start yielding, the principal stresses are sigma 1 is equal to 180, sigma 2 is equal to minus 100 and sigma 3 is equal to 0. That sequence is given as wrong sequence. Positive value we have to assign as sigma 1, 0 value will assign to sigma 2 and sigma 3 will assign equal to 100, but that will not make a difference in calculating the von Mises stress. So von Mises stress is given as under root of sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square divided by 2. So let's arrange this in a standard form such that we have sigma 1 is greater than equal to sigma 2 is greater than equal to sigma 3. So highest value is sigma 1, so that I will assign equal to 180 megapascal. Then the next value is minus 100 and 0. So we'll assign the value of sigma 2 is equal to 0 and sigma 3 equal to minus 100. So von Mises stress we can calculate as under root of sigma 1 is equal to 180, sigma 2 is equal to 0, square of it, sigma 2 equal to 0 and sigma 3 is minus is plus 100. You have to make a square of it. Sigma 3 is equal to minus 100 and sigma 1 is equal to plus 180. Again you have to take a square and you have to divide it by 2. So your sigma prime is equal to 245.76 megapascal. He has used the word yielding. So whenever we have yielding, then we have factor of safety is equal to 1, and by distortion theory we have von Mises stress is same as equal to SYT divided by factor of safety n. Since n is equal to 1, we have SYT is same as equal to von Mises stresses is equal to 245.76. We have to use the value of n equal to 1 when the material start yielding. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.